Here we go. Unit 6, basic integration. So today, and Yannick called it before I was recording, that antiderivative means an integral. And since it's polynomials, maybe they even talk about some basic trig. And let me ask you a question. If sine, the derivative of sine is cosine, what do you think the antiderivative of cosine is?
Would it be like would it be like arc cosine or something like that? Or
No.
Or would it be like
No. Okay, I'll let you chew on this. When we say something's the inverse of the other, it's just undoing it, going back. If I say, if you're adding 2 to both sides, or if you're adding 2 to something, you want to do the inverse by subtracting 2, then what are you doing to get, it's undoing itself. So you get back to whatever you were adding 2 to, because you took away the 2 instead. Like when you got x plus 2 equals to 7, and you want to get rid of the plus 2, you do the inverse. You subtract 2 from both sides. So you end up with just the x equals to something, whatever you did on the other side. It was 7 plus 2, I guess. Was it, what did I write the first time? I said x plus 2 is 7? Right, so that subtract 2. So 7 minus 2 is 5, right? So it's just undoing what you had in the equation one step at a time. Oh, hello. Somebody called and said you were coming. Okay, so the first half is no calculator. Well, you already did that one.
I need the second half.
I didn't grade it though, but it's okay. I forgot you did part.
can I go to the restroom?
Sure, since you worked so hard on redoing a free response problem.
Thank you, sir. I appreciate it. Why is there stuff in the way?
I don't know, is that your stuff?
No, it's Thomas's stuff.
Oh, and that's funny. Thomas puts his stuff way over there and he sits over there. All right, let's get started. If you had to explain to someone how to find the derivative of polynomial type function, what would you say? Polynomial. In other words, p of x equals to some constant, x to the 5 minus a different constant, x to the 3rd minus another constant, x, and to the 1st, and then maybe plus just another constant, a to the a4. So how would you tell somebody to find the derivative of a polynomial? In words. Don't care. I don't care about the a's and the x's. Just what do you say in words? How do you find the derivative of this first part?
Bring the power rule.
Power rule. Exactly. What's the power rule say?
Oh, is the A a constant?
A is all these a's are constants. Yes. What do? You take the what?
The 5 and put it in front of
The power on the x, and you do what with it?
multiply it by the
So when you start out with the derivative of p of x, you're taking that power, multiplying it by the constant, a1, keep the variable and do what with that power? Subtract it by 1. Then if I do the next one minus, I take that power times what? A sub 2, x to the what power? 2. And you just keep on going to all the terms until you do the derivative of this constant, which gives me a 0. So there is really a formal definition of the power rule, if you recall, that f of x equals to some constant, I'll call a x to the n. Well, so the definition of the derivative was, say the same thing again. Do what? Take the power of what?
multiplied by the constant.
Go read it to me.
Oh, is that a 7?
No, it's ax to the n.
Oh. N and A x to the n minus 1.
Perfect. So that's what you would tell somebody. If all you're doing was a polynomial, you'd have to do this to every single term, right? So to find the antiderivative, we need to do
Wait, go back to the formula.
No.
this one right here?
Yeah. Is that times AX?
Yeah, it's n times a times x to the that power. So now we're going to do the antiderivative, which means we're going to do the opposite. So if I start out with, let's say, I wonder if I can do it from this generic one right here. I'm going to try. If my derivative was equal to an n times that constant a, x to the n minus 1, how would I get this back to the function?
Divided by n times.
Okay, divide it.
You have to divide by
Wait,
n.
what do we multiply?
I'm so confused.
Or root it?
You have to divide the n and then somehow like add the 1 on the x.
Well, could we add the 1 first?
Oh, yeah.
Because we go in reverse of the orders.
Or equal to zero?
It was a hit. The class loved it.
Okay, thanks.
Yeah.
One of them.
Yeah. They're actually saying you should quit your day job.
Oh, really?
Yep. So say it again, Yannick.
You have to add the 1.
So we add 1 to what? We take that x to the n minus 1 and I do what to it?
You add a 1.
I add 1 to it, then do what? Remember, I have an NA right here, so now do what next?
Divided by n.
And where's the n coming from? A minus 1 plus 1 actually is NAX to the n, right? So you said divide by the what?
The n.
The n. So technically I divide that whole thing by the n, same thing, and it cancels out, and voila, you're back to AX to the n. Now, sometimes I think that's more work thinking it that hard. I could probably easily give you f prime of x equals to 2x to the fourth, and I bet you there is at least half of you could tell me what the function had to have been.
That's
Maybe I'm wrong. Do exactly the same step that Yannick said. What did he say to do first?
Divide.
No, he did not.
yeah.
Add 1 to what?
The 4.
So what does that become?
5.
X to the 5. And I had the 2 sitting here. Next, I do what? Divide by 2?
No,
Oh, I know.
I divided by
n.
the n. So that is your function. If you don't believe me, go ahead and do the derivative of this function now. What did I do to go? I would take that 5, multiply it by the front, take 1 away, and what does that become? Which is what I had as my derivative that I started out with, and sure enough, it is. So get that in your head again. We, instead of taking 1 away from the power, we add 1 to the power. Instead of multiplying that in front, we divide by it. And what it's doing, it's undoing those operations we had.
So is it just finding the regular function?
You're finding the regular function. If you have f prime, your goal is to get f, going backwards. And the antiderivative is known as, this is how we'd write it. That stands for the integral of f of x, or the antiderivative of f of x. Now, I know what you're thinking. What in the world are they doing here? Sort of like when we did the derivative with respect to x. That's what this means. It's the antiderivative of f, antiderivative of f with respect to x. And you're going to find out what dx actually means. It actually means something infinitesimally small, delta x small.
So if it says that, are we going to have to do
Of just y?
Or like those
As long as we were with respect to y, dy, yeah, you could.
But is that like a thing?
Yeah, it's a thing. Yeah. So in finding the antiderivative of a function, you are finding the original function that you took the derivative of. You're working backwards. This will enable you, even if f prime or f double prime, yeah, you could go backwards from the second derivative, you can go to the first derivative. From the first derivative, you go back to the function. If you want to do it a couple of times, you could integrate it twice if you want to get back to f. Let's say you're at the second derivative. To go backwards, you'd have to do the antiderivative 2 times.
Is there an easier function, like a way to do it?
Well, this is a pretty easy function.
Well, yeah, but is there like a formula for it?
Um,
Or is it just like we have to go back?
yeah, I guess so. If I'm integrating ax to the n dx, then generically that would be ax to the n plus 1 divided by n plus 1. And there's something I haven't talked about. You're going to see that if it's a naked integral, we'll always say a plus constant, but that doesn't, you don't have to worry about that right now. The reason we say plus constant is, why am I going to tell you? Remember this problem that we tried out over here? What if I was doing a derivative of f of x equals the 2x squared that I had, but then I go plus 5? Wouldn't the derivative still be the same? Was it 2x? It was 2x to the, what was it, 2x to the 4th? Where'd I get the 5, right? It was 2x to the 4th. So what if I got 2x to the 4th plus 5? Would that give me the same derivative that I just got a minute ago? Yeah. It would give me the same answer because the derivative of 5 is 0. So your answer could always have a constant in it. And right now, we don't know what the constants would be. Could be anything. A lot of answers. You could put plus 1, plus 2, plus 3, plus pi. But I don't think they're asking us to worry about that. They just want to worry about what I have here. Can you do that real quick? You think so?
What does that symbol mean?
This? It actually means this in you had in pre-cal. It's a summation. It actually means you're adding up. It's really a squiggly S called it's the integrand, I guess it's called, but it's really like an S, which means summation. You'll learn later why. What are we summing up? We are summing something up. So the symbol for summing up is this squiggly S. So if I was to do this one real quick, how do I do that first term?
X squared, x to the third.
Just x to the third? You didn't do any, how'd you jump to that answer?
You add 1 to the...
Okay, you add the 1 to the x, so that's a 3, yeah.
And then you put...
Then I divide that by a 3, but I already had a 3 here. Is that why it went away? Perfect. X to the third. Nice. How about the next one? Plus
Squared.
just an x squared because the 2 over 2 cancels. Great. Plus
3x.
plus a 3x. Yeah, that a lot of people get that one wrong, Julian.
Why?
I don't know. They have trouble with the 3.
Oh.
They have trouble realizing it stood for 3x to the 0. Add 1 to the 0. 3x to the 1. Divide by 1. Nice job, Julian. Not everybody sees that. And there's probably half the class in here still saying,
No, it's not.
yeah. You saw it too?
Yeah, she beat me to it.
Yeah, well,
I didn't know where the dividing part, like if we have to divide. Or
by 1.
by 1.
Yeah. All right. Now, what do you think happens? Because we don't know anything about a quotient rule with integration. So unfortunately, there's that rewrite you have to do because there really isn't a quotient rule for integration. You need to have the terms set up individually. So there actually is a product rule, and it's called integration by parts. But that's in Calculus BC. So we won't have to do a product rule per se. And for this one, there are ways of leaving fractions, but then that's going to be a more advanced method of integrating without having to change this around. There is an advanced method to integrate it, which we'll get to that in a few weeks. So I'm going to rewrite it first. Every term gets divided by x. This actually is probably the easiest way to do it. I'm sort of stuck with minus 4 over x. I don't want to leave it like that either.
You don't want to do the x plus x and negative 1?
Let's see what happens if I do that. Okay. I hope somebody yells at me and says, that was dumb, but let's see what happens. Negative 1. Let's see what happens here.
It's not, you don't have to add it if it's times, it's multiplied?
Yeah, it would be a 4 times x to the negative 1. That's right. If you're seeing something, right? You already see a problem, right? So this probably will be the hardest part of today's. She sees it. She sees a bad pitfall. So if you were to do the derivative, the integral from left to right, what's the first term become?
No, can we just go back to
Is
the
it
other
one?
one?
Is it one?
What other one?
The one where you had it over x.
What about it?
Can you just do that instead of the negative one? It doesn't look right.
Possibly, but you have to have, it may be something you have to memorize.
It's so ugly.
I know.
Because if you add 1 to the negative 1,
What happens to it?
it doesn't, right?
What's wrong with the negative 1 plus
It's
1?
gonna become a positive when it's.
Yeah, what's wrong with the 0?
It becomes 1. The whole thing, right? Because x to the 0 is 1.
Yeah, and so go ahead, keep going.
I don't know.
So you're saying there's no problem. Okay, let's move on then.
Become negative when it shouldn't be. I mean positive when it should be.
All right, let's get to it for a minute here.
Am I right?
No. X squared becomes what?
Is x to the cube?
Over what?
3.
3.
Wait, but sir, where did you get x squared from?
Wait, can you?
No.
You divided the...
Take 2 and add 1 to it.
Okay.
And then divide by it. The coefficient happens to be a 1 in front.
Wait, oh, okay.
Why'd you put a 3 in there?
Because we added 1 to the
It
2.
was an x to the...
It was an x squared.
It was an x cubed. Originally.
It was?
Yeah.
Oh, yeah, I'm blind.
No, but that's what you did say. You divided it all, no?
Yeah, but I thought it was a 2.
Yeah, but you divided
So-
everything by an x.
No, you're good, sir.
Oh, I did divide by x. Yeah, I was right. Yeah, it's not too often I can say that. I was right. So I stand by x cubed over 3, or 1/3 of x cubed. Or, x
Okay, yeah.
x cubed.
Yeah.
1/3 of it. Either way.
Like, unique. The first part, he just divided everything by x. Divided everything by x. When it was x.
So do you agree with this x cubed over 3? What happens to the plus 2? 2x. Because
The one we took when.
Because there was technically an x to the 0 here, right? This is the same one that Jillian figured out. Now, some of you say there's no problem. Minus 4 x to the x to the 0. And somebody back there said no problem. No problem, right? But don't we have to divide by this? Problem.
So it was a constant?
No. No. What we need to remember. All right.
Wait, sir, I have a...
So, yes.
Oh, never mind. I think I did.
Okay, I'm going to post this up and you can finish. So, let me ask you a question.
Wait, no, I have a question then.
Yes.
Why did you make it a 3 again? Like, the 1x?
Add 1 to the power
Oh, okay.
and divide by it. So I added 1 to 2, that made it a 3, and then I had to divide by it. Now, well, actually, it was down here. I already had that. X cubed divided by x, x cubed divided by x is x squared. When I integrate x squared, I have to add 1 to the power and divide by it. That's what happened.
Yeah, I get it.
All right, so let's take this negative 4 over x and just put the negative 4 on the outside and just talk about 1 over x for a minute.
1 over x.
Well, yeah, that's what negative 4 over x means. Negative 4 times 1 over x is negative 4 over x. Wasn't that the problem I have? Isn't that what's there? So I want you to look at this for a minute. The power rule didn't work. The power rule messed up miserably because you cannot divide by 0. I want you to stare at that for a minute and ask yourself, was the derivative of anything ever 1 over x?
Ln.
Oh my God, you're just a genius. So when I do the antiderivative of 1 over x, I cannot use the power rule. I have to say that that answer is negative 4 times the natural log of x. As long as, keep this in mind, that x was the bottom and the derivative of x was 1. Remember that du over u? Whenever you see du over u, then you knew that we were doing the derivative with respect to x of the natural log of u. You knew that we were doing this problem because I had a du over u, which is the answer to the derivative. And in this problem here, if I take that constant of a negative 4 out and leave it just as a 1, and I call my x as my u, the derivative of x is 1, perfect. Jillian nailed it. So over here, I'm going to get rid of that piece of garbage and write minus the natural log of the u, x. So I'll rewrite the whole answer. Equals to x to the third over 3 plus 2x minus natural log of x.
Oh, not a 4 natural?
Oh, yes, I'm completely messed up. Minus 4 natural log of x, yes. So that probably was the hardest thing because it didn't match up with what I was telling you to do. And I have to ask myself a big question. Why did the author throw that in? You know, it didn't match up with the power rule. But at least we got it out of the way if it comes up again. So I want you to think about whenever you see fractions, check to see if you have du over u. Yes?
How many units are there in calculus?
We have 6 is the biggest unit that we have left. And then if I even don't go and do 5, we'll be okay because a lot of stuff in 5 comes up here in the 6. There's a little bit in 7 when we start talking about finding volumes of revolutions or a volume of a solid on the desk, how to find the volume of it, where we cut it up into pieces. And so I'm going to say it's 6.5.
So we're almost done.
Yeah. But don't get me wrong, this unit is 30% of the test, so we got to really do well on it. It's all right. Okay, now I did that. That one, okay, somebody asked, there's no power rule right now. I want you to make this into a polynomial. Oh, you want to, what is that called? So instead of using a power rule, she's using a product right now. She's just going to multiply it all together. So her rewrite becomes, say it again, 2x squared?
2x squared.
Uh-huh.
Hold on, I need time to think.
Minus 3x plus 4x minus 6. You can leave it like that, but I know Jillian's not that way. She's going to say, I need to probably simplify that. But she doesn't have to. If she didn't want to, it'll still work out. 2x squared plus an x minus 6. Okay, now it looks really easy. I think most of you could probably give me the antiderivative super fast. Is 2 X what?
Over 3.
Over 3.
X cubed.
X cubed. You did it kind of reverse what I was thinking. I always do the power first, then say divide by 3, but yours is good though.
Oh, yeah.
Go ahead.
It feels like when it's like x squared, is it always just gonna be
X
that
cubed.
number divided by
3. Yeah. And guess what? If it's x to the 5, it'll always be x to the 6 divided by 6.
Incarnate.
Yeah.
what about x to the fourth?
I'm glad you asked. That'll be x to the 5 over 5.
So is it that for all even or all?
Polynomial terms. Yep.
So if it's let's say it starts off as x cubed,
Yes.
then is it the number divided by?
It's 4 over 3.
Yeah.
X to the 4 over 3. Right? Or over
No,
4?
it's still a-
Over 4.
It's over 4.
Yeah.
Once you add 1 to the power, that's what you divide by.
So it's so it's always gonna be like is it that's how it works for every single
For polynomials.
for polynomials.
Yeah. Algebraic terms. Yeah.
So what have we been doing?
Well, we just threw in a natural log garbage right now, so it has nothing to do with the algebra. So he threw that in there to make us sweat. I was sweating. I had bullets of sweat coming down saying, oh my God, how are we going to get out of this mess? All right, next one. The X.
I'm confused.
Me too.
Squared over two.
Yeah,
Oh, yeah, you're right.
Wait, what?
I'm getting it now.
Oh, okay, I get you.
Because there's an invisible 1 power.
Minus 6x.
Minus 6x. Wow. And get in the habit that there's also some constant that it could have been, because you could put any number there and do the derivative from left to right. You're going to get the same thing as you started out with.
So do we always have to put plus constant?
He's not pushing it, but yes.
On the AP, you put plus constant.
If you're doing this integral that has no numbers with it, because right now we call this, I don't want to bore you with facts, but yeah, if there is a constant. Because to check your work, you'd have to do the derivative with respect to x of your answer. 2/3 x cubed plus 1/2 x squared minus 6x. Well, when you do the derivative of this, it needs to come back to, I'll circle this. You have to get when you do the derivative of this, it has to be this. But if I had a plus 4 here, it still will be the same answer.
What's 2/3 times
2.
3? Whoa. I knew that.
All right. How about this one?
Do we make it a product do we make it like a polynomial?
Yes, well, since it has a rational exponent, it's not called a polynomial, but it's polynomial-like.
Yeah.
Yeah, so how would I change that?
2 times
2.
x to the negative 1/2.
Beautiful job. So now, take your time. I need to add 1 to a half.
3/2.
So I have my 2, I have my x, and you're telling me it's 3/2, right?
Yeah. Wait. Yeah. Half.
Oh, I thought I heard you say 3/2.
No, I messed up.
Okay, so you're telling me it's a half.
Over.
So now I got to divide by a half, and here's how I do it. When I divide by a half, I do 1, 2 on top.
Oh, because it just multiplies.
Because I'm multiplying by the reciprocal. So I go, when I divide by 1/2, and I'll erase that step to show you, if I divide that by a half, it's the same thing as taking 2x to the half times the reciprocal of half, which is 2 over 1. So to me, it just makes more sense to say 2x to the half, divide by 1/2, and put the denominator up there, and you get the same answer. 2 times 2 is 4 square roots of x. And you can say plus c, so 4 square roots of x plus c is a perfectly good answer.
Can you zoom back in real quick?
Do what?
Can you zoom back in?
And if we were allowed to give you guys homework over spring break, I'd give you 100 integrals to play with.
Okay, sir.
No, you know what I used to give? I used to actually give your first full AP exam during spring break when I was working for other places. And on that test, you would find out that even as of right now, you're almost passing the AP test. You're this close. With the knowledge that you have, you're this close to passing an AP test right now, today.
You're iconic.
Stop it.
So, sir,
I saw you talking to Mr. Flores. He's iconic
No. You're much more iconic.
so
in my own head.
after like April, we're gonna just start prepping.
Yeah.
AP.
Yeah. Well, we need to get through a couple full AP tests.
How many?
I'd like to do one with you, and then I'd like you to do one on your own.
Like with us, meaning like we'll all.
Yeah, we model it. We work out each problem together. Like, you know, you do a couple problems, and I'd go and follow through with those two problems, show you what I think stands out. Yeah, right. Go ahead. It's already signed. That's my goal, but you, huh?
When?
When? Well, Brown, yeah, we got to get through March, and which is not got to get through March and sometime in April. We got at least a couple weeks where we need to just hopefully call it what we have and see what we can do. All right, here it is. We have learned that the derivative of sine is cosine. We have learned that the derivative of cosine is a negative sine. So now, knowing this information, this is sort of like when I asked you, do you remember the derivative of something was equal to 1 over x? And then it was Jillian who said, oh, the derivative of ln of x was 1 over x. So I'm telling you that the derivative of sine is cosine. So if I'm integrating cosine, if I integrate cosine, what do you suppose the original function would have been?
Negative sign.
Sine.
It would be sine. That's right. Because look what's here.
Oh, I got it.
Now it gets hard right here. If I'm integrating sine,
Negative cosine.
why? Where are you getting the negative from? Okay, yeah, I'll take it.
Because
Thank you. I'll do that.
sine should be negative.
Right, because there's this blasted negative here, has to go somewhere, doesn't it? So when you say that the integral of sine is cosine, but really you needed to have a negative sign to get the cosine. So you're right, negative cosine. Okay, so how do I remember this? Remember when we said the derivative of sine is positive cosine, and the derivative of cosine was the negative sine. So now it reverses. The integral of sine is negative cosine, and the integral of cosine is positive sine. It reverses which one gets the negative. I mean, you can look at it that way. So if I'm doing from left to right, what is the integral of sine?
Negative cosine.
Okay, so this is going to become a negative 2. The constant just comes with it. Cosine of x plus what?
Cosine.
Plus what?
Sine.
Sine, yeah. And I still have my constant that I like to play with there. Go to the right. Let's see. Oh, combinations. Left to right. T
T to the third.
divided by,
3.
you finally have it, Yannick. Minus what?
Cosine.
Minus cosine. Yeah.
Minus cosine or minus cosine?
No, minus cosine.
The derivative of sine is
Oh,
cosine.
plus cosine.
It becomes the, yeah, so that, cosine, so that turns into t cubed over 3 plus, like you said.
No exponent?
Nope, not with this, no, not with this piece, no.
Would there be if it said like in the first example, it says 2. Oh, never mind. The x is.
It was a coefficient.
Okay.
All right, do another one. Left to right, 4x becomes what?
4x squared.
Yes, 4x squared over 2. And I realize I have a rewrite I could do after I'm done, but I didn't want to sweat it, okay? And y plus?
Because the derivative of
Cosine is the derivative of the integral of cosine is a positive sign. So that negative stays there?
Yeah.
It does stay there.
Yeah.
Now, if you want to make it prettier, you would call it x squared with a 2 in front, minus 3 sine of x plus e. And, oh, we kind of did the square, no, we didn't do a square root like that before.
We did it under
We had it under. How's it different now?
the top.
So I would write it as x to the 1/2 plus sine of x. Let's see if that stumps you.
X to the 3/2.
Yeah, x to the 3/2. Watch me. Divide by 3/2.
So it's times 3 divided by 2.
No, times 2 divided by 3.
Minus cosine x.
Oh, yes, minus cosine of x.
Wait, but if you have to divide by 3/2.
Which means multiply by 2/3, right? Reciprocal. So that was a pretty big mouthful that we have just practiced on. I mean, I feel like, wow. What does he jump? This guy who writes this stuff, I mean, it's good because it makes us, every lesson is connected to other things that I'm not expecting. Use the given information about f prime and f double prime to find f of x. I don't have f of x here. So I start with f double prime, and I will antiderivative f double prime to give me f prime. Does that make sense? Yes. Then I will antiderivative f prime will give me what? F of x, which is what I want. So let's start with this. What is my equation for f double prime? So I'm going to go simply integrate 2 dx. I add that dx. The integral sign and the dx go together like a sandwich. So when I integrate 2 dx, what do I get? 2x divided by what? 2x. But remember what I told you? There's this constant. Am I going to need that? Let's see. He told me, now what does this become? This is my f prime, right? He's telling me that f prime at 2 is 5. This is my f prime. I need my f prime at 2, meaning I take my 2 times the 2 right here, plus my constant equals to 5. Why am I doing this equation?
So you can figure out the
Which constant did he have? Exactly. So what constant did he have in his original f prime?
1.
You're right. Well, that's why she said 1. I was ignoring her because I thought, I don't know what she's talking about. C is 1. So what I have to do now, I now have to integrate 2x plus 1 dx. This is my f prime, and I want to make an f out of it. So what am I doing? I'm integrating this whole thing. And when I integrate this, what do I get? This is my f now. What am I getting?
You get 2x divided by 2.
2x, just 2x
Hold on.
Sir, can you help me with a question?
Yeah, 2x squared.
divided by 2
Yeah.
plus
Plus c.
x plus the constant.
Where you get the x? Oh, yeah.
Yeah, it's 1 times x to the 0.
Plus x plus c.
Mr. Cartwright,
Yeah.
can you help?
I don't know, Cassie.
I keep replaying
Sir,
it.
can you tell us your
like redoing this in my head and I get the same answer every time, and the answer isn't on the answer. Like, it's not there.
It's not there. Maybe it's a bad quiz.
I don't know. Like, okay, look, sir.
Right there's a pass. Did the last person come back?
So, let me walk you through the steps here.
Wait, I gotta stop recording you.
Oh, sorry.
Oh, we gotta find F. Well, I have F, but it has a constant in it. Did he give me any information about F? He certainly did.
Sir, wait, how did you get C, the constant equal to 1?
No, the x integral of x of 1 became x. You always have a plus c.
But why C equals to 1?
Oh, up here, because we had 2x plus c, right? He told me up at the top that the first derivative at 2 is 5. So I took the first derivative. This is the first derivative at 2, which gives me 2 times the x, which is 2 times 2, plus that constant, has to be 5. I just solved it for c. 2 plus 2 is 4. 4 plus c. Take away 4 from both sides. C is a 1. So that created the whole equation of the derivative. So I wrote the whole equation of the derivative right here. Then I integrated that equation, giving me x squared, basically x squared, because the 2's are going to cancel, plus the x, plus another constant. Now, this constant here is really technically a different constant than the one that was up here. That's a different constant. That's a different one. So anyway, this is my F, is this. But I got to find out what the constant is. So I go up here, and he tells me that the function evaluated at 2 will always be a 10. So I go here and I say, the function evaluated at 2 will always be a 10. So I'm going to plug in a 2. So that gives me 2 squared plus a 2 plus that constant. That gives me 4 plus 2 is 6. 6 plus the constant still is 10. This constant must be a 4. So the actual equation of f, the full equation of f of x, would be my x squared plus x plus the 4.
Okay, I get it now.
It's a lot. This is heavy.
You're uploading this, right? The video?
Yes, the video is recording. I will upload it. Send the tips to my PayPal with my email address, and I'll appreciate it. All right, let's do another one of these ugly things. We're starting out with the second derivative. We're going to integrate that to get the first derivative. We integrate that to get the function. Each time I integrate, I always introduce a constant. Cassidy, you're cheating.
I already turned my quiz.
Oh, you're not cheating. All right. So, oh no, it's going to be live for everybody to hear you.
Oh, really?
Yeah, we're recording.
I wasn't cheating.
She was not cheating.
He just randomly accused me.
I randomly, wasn't random, I purposely picked you. Randomly would have been, close my eyes and say, Alfredo, you're cheating. Yeah, that would have been random. I purposely picked on you. All right. So integrate x to the negative 3/2 dx. This is going to give me my f prime.
X to the negative half.
How'd you get that so fast?
I was thinking about it way before you started.
All right, you take the x, you add 1 to the negative 3/2.
Divided by negative.
That gives me,
So is it times negative 2?
well, when I add 1 to negative 3/2, what does that give me? Doesn't that give me a negative half?
Yeah.
Divided by a negative half?
So isn't that times 2?
Go over the square root of x. I don't get it.
Okay, well, yeah, I'm gonna leave it like that though. I might rewrite plus my constant. You want to change it? I'll change it to this. Negative 2x to the negative 1/2 plus my constant. What, you wanted to change that to 1 over the square root? Is that what you wanted?
That's what she wanted.
Okay, negative 2 over the square root of x plus my constant. All right, so that's my f prime. And I go up here and realize, look what he said. F prime at 4 will always be a 2. So this is my f prime. This is my f prime right here. So I'm going to take my f prime, evaluated at 4, should be a negative 2 over the square root of 4 plus my constant has to be how much?
4,
Nope,
2.
a 2. Has to be a 2. So I do very careful, and I try to solve this. What's negative 2 divided by the square root of 4?
Negative 1.
Negative 1 plus my constant is 2. My constant must be a 3. So my f prime is really, I'm going to integrate my f prime, which is really going to be 2x to the negative 1/2 plus the 3. Why did I leave it with the exponent on top? So I could do my antiderivative again. Because right now, this will be my f. When I integrate my f prime, I'll get f. So what's the integral of 2x to the negative 1/2? Add 1 to negative half. A half? X to the half divided by 1/2.
So it's times 2
That's right. Plus
plus, hold on,
3x. Plus
C.
a constant. This is my f, guys. This is my f with a constant. But that constant could be anything, but not in this problem because f of 0 is, oh, okay. So f of 0 would be 2 times the square root of 0 plus 3 times 0 plus a constant has to be 0. So what's my constant for f?
Wait,
0.
My constant is 0. So my real f of x is 2 square roots of x plus 3x.
sir,
Yes, sir.
when it's the 2x to the 1/2,
Yes.
don't you multiply a 2 to the 2?
I did.
You forgot the 2 on top, sir.
Yeah, the 2
Oh.
on top,
It's not the 2 yet.
2 times the square root of x. It's right here.
No, but there should be a 2 times the 2 x to the 1/2.
Because it was 2x.
Oh, 2. There was times another 2.
Yeah. Sir, I think that's,
Oh, yeah, you're right. So that's really a 4 then, right?
yeah.
A 4? That's really a 4? It was. Thank you.
Extra credit or what?
Yes, Yannick. Yannick. Extra. All right. Those are hard, guys. If I was to watch anything at home on this video, I would watch those two. Is there anything else? It's there. No, I took it already. And then if I did have it, I couldn't even give it to you though. I'd have to just show it to you and say, yes, I have one, but I can't give it to you. Ha 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 ha. I'd lose my medical license.
You have a medical license?
No. All the more reason why they don't want me to have one. You're thinking about giving it to a teenager? All right. A evergreen nursery usually sells a certain shrub after 6 years of growth. And of course, they're doing a lot of shaping it. Julian,
I'm sorry, what?
how long do we keep the shrub before we sell it? 6 what? Years. Okay. The growth rate for those 6 years is approximated by this differential equation. It's a derivative. But don't let this scare you guys. This is no different than dy dx.
Why?
It's a derivative.
Why?
But what I want you to do for a minute, I want you to pretend that I could multiply both sides by the dt. Okay? I want you to realize that this means the change of height of the shrub is equal to 1.5t plus 5 dt.
What?
I multiplied by this denominator. That's typically what we do with the differential equation. Now, my calculus teacher in college would get mad at me for saying that I multiplied both sides by dt. You really did not do it. what we really did is called separating the variables. I separated the dh and the dt so that I could put the dt with the function. But for you and I, normal people, it looked like I multiplied both sides by dt. But in math talk, we separated the variables. Now, you might be asking, why would I do that? Because look what he's saying. Time, t is in years. Height stands for height in centimeters. The seedlings right now are 12 centimeters tall. That means this, guys, when t is equal to 0, when I buy my plants, my shrubs, they're already, the height is 12. I wonder if that stands for an initial condition like we did at the top, where when x was 0, y is equal to 12. I wonder if we could think of it like that. But anyway, find the value of the differential equation above when t is 3. So when t is 3, find the value of the differential equation. I just plug it in, that's right. If he just wants to know what the differential equation is, if I just left it as dh dt and plugged in the 3 at 3, I'm going to put t is 3. Would that look like 1.5 times 3 plus 5? What does that give me? Yeah, it would. Try harder.
It would be a 4.5
Plus
9.5.
9.5. What would the units be? It's a rate. Just like, remember your related rates? What does dh dt mean?
Centimeters per year.
Height per
Year.
year. So what's the variable of height?
Year. Right?
Centimeters per year. I heard it. Thought I heard it. So in other words, as the shrub is growing, the change of height when the time is exactly 3 years, if you could stop time, the shrub was growing 9 centimeters per year at that very moment.
Wouldn't that mean that for 3 years?
In 3 years, that's the rate it's growing. Every year it's growing 9.5 centimeters at that moment. Now remember, it already was 12 when we bought it. So what do you think, how high is it right now in 3 years exactly? Roughly, can you estimate it? 21, yeah, plus the 12, right? Because we already had 12. So that's an estimation. Now, mind you, year 1, it may not have been growing that fast. Year 2, it might not have been growing that fast. Year 3, it was growing that fast. So you're taking the maximum speed right now and using it for all 3 years. So it's just it might be an over approximation. What else did he want? For the equation for h of t, wait, I have an equation for, well, I don't. Do I have an equation? No, I got to find it. Interesting. I wrote this up here. dh equals to 1.5t plus 5 dt. How could I get an equation for h out of this? Say it again, louder. If I integrate the left, what do you suppose when you integrate dh, what do you think comes out? When there's an imaginary 1 here? H. Nice job, Thomas. That's extra credit. So yeah, when you integrate dh, there's an imaginary 1. The variable was h, so it comes out to 1 times h divided by 1, basically. So h of t is the equation. But you can't just integrate the left. You have to integrate the right. And what happens when I integrate that?
It would be 1.5t squared divided by 1.5.
Nope, divided by 2.
Divided by 2.
Plus
5t.
5t plus C, right? Well, I don't want C in there forever. Can I find the exact constant that the height function was? Do I have any information about the initial condition? Yeah, I know that when time was 0, the height was 12. H of 0 is 12. Yes or no?
Yes.
Is that just like what we just did up the top?
Yeah.
So I got to plug in a 0. What happens when I plug in a 0 into this?
0.
0. What happens when I plug in 0 into this?
0.
What happens when I plug in a 0 into C?
C.
C. So what is C?
12.
C is 12. So what is my height equation for real? Height equation for real is
1.5
1.5
over 2
t squared over 2, right?
plus 5t.
Plus 5t plus 12. Now, I can ask the question better. How tall was it really in 3 years? How tall? You had an estimate. You gave me an answer, 21 something, right? I wonder how close you were. And I told you I think that's an over because that rate of change stood for 3. It could have been slowing down or speeding up. I think as a tree grows, it probably gets it probably grows slower at first, then seems like it gets bigger. But I'm just guessing. So if I take 3 and plug it in, you might have to use your calculator. 3 squared is 9. Can someone do 1.5 times 9 divided by the 2, please? 1.5 times 9 divided by 2?
6.75.
Okay, hold that. Add that to 5 times 3, that's a 15. Add that to 15.
21.75.
Plus 12.
33.7.
Oh, actually, we were under.
Yeah.
It's actually 33. Unit?
Centimeters.
Centimeters. Right, centimeters.
Oh, just not for you?
No, because this is just h, the height. That was exactly centimeters. So when t was 3, we have a height of 33 exactly?
No. 33.75.
Oh, 0.75 centimeters. Is it ready to cut? Well, no, because we got to grow for 6 years. Hey, wonder what this would be if it went 6 years.
Probably the double.
Probably that, but doubled, probably. Yeah, maybe it is. I'm not going to figure it out, but. All right, last thing. You do know your relationship between derivatives, right? If a function is moving, f of x, that's a position. How high is it, right? What is it called when I do the derivative? Position turns to what? It's velocity. What's the second derivative? Acceleration. What's the third derivative? I want to make a shirt for this, though. Velocity, acceleration. What's after acceleration? Third derivative. It's called the jerk.
The jerk?
It really is. So I might make a. Wow, never thought I'd see that. I'll never get that out of my head again. I gotta go home and pour some bleach in my ears. Now, so I'm gonna make a shirt that has the third derivative. Say, you are the third derivative. You know. Yeah, just walk away. No, I'm not gonna do the dance. Only Cassidy can do that. All right. So look at here, guys. All right, I can tell we're not interested. Let's see. If the homework has this, I got to. Even though I haven't done anything yet, the idea that the position function right here is position can be used to find the f prime, which is the velocity function, and then v prime, which is f double prime, becomes the acceleration function. So now that I can do that, I already have the v function. So let me start out with v of t. V of t, according to the author, is that
It's 1 over square root.
Oh, is there a negative in front or no? 1 over the square root of t?
T to the negative half.
Oh, right, t is the negative half? That's a good idea. Anything else? That's it? That's the whole function? So if that's already a derivative, that's already the first derivative. Now to do acceleration function, I would just do the derivative of the velocity function. So that would be what?
-1/2 T to the -3 halves.
Negative how many halves?
Negative 1 half.
3 halves.
3 halves, that's right. Now, that would be my acceleration function. What is the acceleration of the particle at t equals to 9? Well, that's just the acceleration at 9. That's the t right here. So I plug that in. I get 1/2, or negative 1/2, I should say, right? Negative 1/2 of a 9 to the -3 halves. Now, who has the gun is to try to find what 9 to the negative. If you guys got calculators, you could actually do it. Yeah, -1/2 square root of 9 to the 3rd power would be correct, right? If that confuses you, you could take -1/2 square root of 9 times 9 times 9. And if you break that apart again, -1/2 square roots of 9 times square roots of 9 times square roots of 9. So without a calculator, you could still figure that answer out, because that's a 3 times a 3 times a 3 times a 2, which is, I don't know, how much is that?
729.
How much?
729.
So it's -1/729.
Square root
Oh,
of 729.
oh, the 9 times 9 times 9. Oh, you're saying that, but I still have a 2 here then.
Yeah.
Okay, I get.
2 times 27.
Oh, but wouldn't it have been easier to have done -1/2 times 3 times 3 times 3?
Yeah.
So with just a calculator, without a calculator, I could say 3 times 3 is 9, times 3 is 27, 27 times 2 is 54, -1/54. Is that the same answer you had over there?
Yeah.
Now, what's with the units? What's the unit?
Not something per second.
Per second squared. Did he tell us what the units were?
No.
Oh, there's no units. So I don't need to say it. But if it was inches, we would say inches per second squared if it was seconds. That's acceleration, but we don't have to put it in. Now, what if I chose to write this as a decimal? Some of you I got really tough on the grading that last test. There were people that lost a point or two because they put these crazy decimal answers. What would I have to write down?
-0.019.
And is there a reason you went at least these 3?
Oh,
What if you would have just said -0.02?
It's not accurate enough.
I would give no point for that.
I was,
It has to be 3 decimals if you choose to go decimal. Please put that in your head. You're going to lose points on the AP test. There's only 9 points on a free response. Why do you want to give up one of those? Because you didn't put 3 decimals. Especially when you have a calculator. It's a calculator section. They expect you to use a calculator. I could have done the whole answer with just a calculator. I didn't even have to. I could have told the calculator to have done the derivative and plug in the 3 or the 9 when you get around to it. And you could have the calculator do the whole answer. I didn't have to do the derivative. If this was a calculator test, I would not have to show anything but the answer in the correct units and the 3 decimals, if that's all they were asking for. I'd have to say A of 9 probably is approximately that answer. All right, enough hitting your head on that one. Uh-oh, what is the position when t is 9? Where on that number line was that particle? how do I get position if I was given this velocity function equals to negative, no, it wasn't negative, you said. It was just t to the negative 1/2, right? How am I going to get position out of there? Integrate it. Yeah, I got to go the other way. I got to go backwards. So I need to figure out that a of t will be the antiderivative of v of t dt. Does that make sense? With,
Isn't it P?
oh, position. You're right. Thank you. Position, not velocity. I was velocity on the other one. I went to velocity to acceleration. Now I went velocity to position. I can call it v of t or p of t, or a lot of times textbooks call position s of t. Physics, it's very common. I don't know why, but s is very common for the position function. In calculus, I see a lot of people put p because it stands for position, and it doesn't really matter. Call it what you want. So I need to take the antiderivative of t to the negative 3/2 dt. What was the rule that we learned? And I'm sure you all did your homework, so you remember the rule, right?
Add 1 and divide
Add 1 to what?
by the x.
Okay, so she wants me to add 1 to a negative 3/2. So what does that become? Yes.
Wasn't it already T to the negative 1/2?
It was t to the negative 1/2.
T to the,
So you made it T to the negative 3/2.
Oh, negative 3/2. Is that what you said and I didn't listen to you? Jillian?
I said t to the, no, Unique's right, t to the negative half
Yeah,
over.
and then you made it T to the negative 3/2.
No, it was already t to the negative 1/2.
Yeah.
Wasn't it?
That's a 3.
Oh, it was 3/2?
No, it was.
Oh, I wrote a 3.
Yeah.
I must have been thinking of the answer. I don't know. So it was a negative 1/2 becomes a what? Negative
Yeah.
positive 1/2. How could I be thinking of the answer, sort of? That was weird. Oh, then divide by the what? So that would be divide by 3/2, which means divide by 3 halves.
Divide by half.
Oh, it didn't. Why do I?
From the last time,
Yeah.
the other problem.
Okay, I'm going to start over. Welcome back from spring break, right? Why is that not erasing? Erase abracadabra. Okay. All right, let's make sure we agreed. We said the function, function is negative 1/2. Did I write it wrong here? Yeah, I see it's a negative 1/2. I don't know why. Maybe I just couldn't read my own writing. Negative 1/2. So I'm integrating the negative 1/2, and you say that becomes s to the, or t to the, how much? 1/2 over 1/2. Anything else?
Plus c.
Plus the constant. I got to get rid of the constant, so I hope he's given more information.
Oh, well, it says that 1 is 4.
Oh, there it is. We call that an initial position. As initial as he could possibly go. He could have said it 0, but maybe there was no data for 0. So you don't really need the initial. In other words, the very first position in the world. Any position will do. But for our practical purpose, we call that our initial position. So I need to say S at 1 equals 2 square root of 1 plus C has to be equal to 4. Because what I'm going to do is I'm going to use this component here to find out what C is. I take the antiderivative, plug in the x value, set it equal to the y value, and then solve that. 2 square roots of 1 is just a 2, isn't it? So C has to be what? C has to be 2. So we'll write out the correct position function. S of t will be, we said it was 2 square roots of t plus 2. Would that be right?
Yep.
and we'll run with that. So there's your basics. That was the last part. I hope that wasn't involved in the. No, we have T as 4.
No, and part B.
Oh, down here was at, find the, okay, that is my position function. So you're telling me that I didn't finish the problem. S at 9, where is it at 9, whatever it stood for, seconds, it's time of some sort, would be 2 square roots of 9 plus 2, 6 plus 2, 8. Positive 8. So on the number line, I can tell you that the position is right here at 8. That's where the particle is in 9 seconds. Who knows what that particle did before it got there? That particle could have gone crazy. Well, I know at 1 second he was at 4. So at one time the particle was here at 4. That was at 1. T is 1, but now T is 9. We're out to here. So we don't know what that particle did. That particle could have bounced all over the place. And then it finally landed here. Yes. Yes. I think I have one right here. All ready for you. Okay. Yeah, it is the last. Teach it. If the homework doesn't have it, I won't. By law, I have to say it's due tomorrow because I can't assign you homework over the spring break.
But by, the technicality is due when we come back.
Homework that you had. These are all just basic antiderivatives.
Asking for the position when T is 9.
Oh, we had to do T as 9? These are just basic antiderivatives. You didn't have to find C, but you do write C. Teach it right now.
We worked pretty hard.
You did. Luck. I am going to cover it when we come back, but you got a homework, and by law, I have to tell you it's due tomorrow. Even all the way through number 12. 13 and 14 is where you're going to start finding out what C is based on the data that was given. Was there another? Did anybody have trouble with 13 and 14? They weren't as mechanical. They were a little more thinking than.
I didn't get that.
You didn't get those 2 problems?
No.
Well, you have it now, right? I hope. Okay, so what problem did your homework go up to?
12.
It just went to the 12, and I didn't give you those 2 problems? Okay, or I'll have you add those, and then we'll touch base after then. Well, we can, before we leave today, we can grade those 12, and then go ahead and do these other 2. Okay, you're on the page after this. There wasn't. Well, let's move on to an application of antiderivatives. Why would we talk about an antiderivative? Well, you just found one reason. I have a velocity function. I want to find out what the position function was. Yay, that's so exciting. I know every one of you is going to be a rocket scientist, so that's important to you. Chances are it doesn't mean that much, but there's actually a lot of situations, a lot of functions that even in the medical professions that you would want to use antiderivatives. But right now, there's something called Riemann Sum. And the name Riemann comes from mathematician. I want to say it was an Indian mathematician, but then when I post this online, somebody from another place is going to correct me and say, no, it's not. So I don't remember where Riemann was from, but Riemann realized that some functions are very hard to integrate. Very hard. So they came up with an idea of if integration is simply the area under a curve bounded by the x-axis, then I don't always need the exact answers. If I can't figure out how to integrate the function, then let's do some approximations. That's what this is about. It's about realizing that the integral of f of x dx represents the area under the curve of, I'm going to just draw my function in red here, And I'll draw this function. So if I'm only going from A to B, then the area under that curve would be exactly that amount of area, which would be really hard for us to calculate by hand because it's not a rectangle, it's not a circle, it's just this weird curve. And how much paint do I want to buy? I don't know. I don't have a formula. So what we're going to do is Riemann realized that we could divide our function into rectangles underneath it. And rectangles can give you an approximation. So was there anything else he wrote up here? It's basically the same thing I just said. From A to B, it's an estimate of the area of the curve. That's what we're going to do. We're going to draw. And so his first ones are called left-hand Riemann sums. What does that mean? Left-hand Riemann sums means if I was to draw a rectangle and I have some intervals here that I'm going to use, I would say let this rectangle here, if I go up here and make a rectangle, I'm going to make the left side will be predicting the height of that rectangle. Left-hand rectangle. So this rectangle here that I'm looking at right here, I make my line, I go up, touch the function. Then I go from where that is up at then I go to the left again. See that? Then if this was my last rectangle, I would still do the left of this rectangle here, you see? Go up to the function, and then I go out and make a rectangle. Now, if I was to go back to this piece that I didn't use, it's already at touching the function here, so when I go left, that's the rectangle it makes. It's on the x-axis. You can see that that's not going to be an accurate area under the curve. Area is very easy rectangle, length times width. Length times width, length times width, length times width, length times width. But you don't have to be a genius to realize that that area is not supposed to be in my answer, but it is going to be because I'm estimating. What else can I notice? Look at here, this rectangle ripped me off some area that I'm not using. You what? It's a fraud, yes. I'm ripping off some area. So this one's too much, this one's not enough. This one gave me no area because the height is 0. So look at all this area that I'm not even using in my estimation. Well, we're going to find out that more rectangles are better because then I can minimize the over and the under. So we're going to start out with this function, f of x. It's an upside down parabola. It's already graphed here. We're going to go from a negative 1 to 7 or 1 to 7? 1 to 7. Well, I want to draw. 1 to 7. I just don't know. Oh, I'm not marking it. 1 to 7. So here's my 1 right here. So obviously, if I go all the way up to the curve, there's the ordered pair. Now, he gave us the ordered pair, but I think if you wanted to, you could find out what f of 1 was. F of 1 will stand for the height of the first rectangle. Why am I using that as the height of the first rectangle? It's the left side. If 1, and 7 ends over here. But I won't be using that as a height because that's the right side of a rectangle. I want to use only, in this case, left. Not because there's any magic to left. There's not. And so if I plug in a 1 in my quadratic, let's see, I'm predicting around a 7. Is it a 7? Anybody? Negative 1/3 plus 2 plus 5. I guess it's not exactly, the dot wasn't really exactly there, was it? Let me erase it. Nope, it's not really at 7. There, you would never be able,
It'd be like 6 and 2/3.
6 2/3, something like that. Yeah, see, it's definitely not up to 7. So you have to find out then exactly how much it is. And say, how many rectangles do I want? He wants me to create only lengths of 2. He wants lengths of 2. The rectangles to have lengths of 2. That means when I say length, that's the bottom of the rectangle. Who was just back? Come and get it. So if I'm going to go lengths of 2 and I'm starting at 1, where would that rectangle end at? 3. So here I go, going up, going up, going up, going up, touching the function. Both of these, I'm touching the function. But which one determines the height? The left. So I'm going to go to this dot right here, and I'm going to cut it over, okay? So then I go to the right side of that rectangle. I need 2 more. Where am I going to go?
Wait, are you gonna do the dot
I'm going to the dots.
for f of 1?
Yes, I'm going to use this point in a second, yes. I do need to know what f of 1 really is. I know, I thought it was 7. Yannick said it's 6 2/3, but we need to really plug it into the function to see what it really is. Yannick might actually be right. It might be 6 2/3. So here's my second rectangle. I'm ending at 3, add 2 more. There it is, up to the dot. And you'll notice that the left side goes out to here. And I got to make sure, I was doing lefts, yes, okay. So there's another rectangle. And then I have room just for one more rectangle to get to the red line that I drew. That would be the bottom is down here. You see that? You see that? 5 plus 2 is 7. Takes me to here. And so I have to use, again, this dot right here. And wow, that's a lot of wasted space I'm not going to be able to account for. So in reality, the only area I'm adding up, let me just shade it in here, is all of this blue rectangle, all of this black rectangle, all of it, guys.
Why does it go up so much higher than the first one?
It has to go to where it touches the function.
Why can't the left one go up?
Oh,
The left one of what? You mean of the blue?
Yeah.
Because he wants left-handed. Left-handed means the left side of the rectangle is going to determine the height.
Oh.
We could turn around and do right-handed and you know, blow our mind out and say, oh, we got another answer. And we will be doing left-handed, right-handed, and get this, we'll also be doing midpoint. Yay. So the green rectangle only can go to where, at this 5, to when I touch the function right here. And it goes over. So I'm getting all of this answer, all of that area. And if I add up the red, the black, and the green, it would be an approximation.
oh wait. Okay.
So area will be approximately length 1 times width 1 plus length 2 times width 2 plus length 3 times width 3 because I only have 3 rectangles. And if he'd have told me I want 3 rectangles with the width of 2 from 1 to 7, I would have drawn the same picture, except if he would have said left-handed rectangles or right-handed left rectangles. So the only thing I can say is all the widths are the same. They are what? 2. So my area is approximately f of 1, because that's the left side, times 2, plus f of 3 times the 2, plus f of 5 times the 2. Or if you were smarter than me, you would have said, why don't I just factor out the 2 of the whole thing and go f of 1 plus f of 3 plus f of 5. And if you're good with your calculator and you plug this function in your calculator and go to your options to find the values of the function, you could find the value at 1, the value at 3, and the value at 5 in like 30 seconds. And you won't have to do the hard work. Practice that with your calculator, please. This is something you don't want to spend a lot of time with your brain. You just want the answers, just the facts, ma'am, just the facts. And so if somebody could tell me what f of 1 is, okay, so I'm going to put, since we always want 3 decimals, I'm going to at least give 4 or 5. 6.6666. I'll go 4 here. Plus, oh, I forgot my 2. Plus what? What is f of 2 or 3? Exactly? Oh, that's easy. And f of 5 was? 6.6666. I'll give the 1 extra. And now it's going to still be 2 times, add those numbers up. Well, that's 12. That's 20. Looks like 20 plus 21 something. 21.3333. Okay. So if you wanted to keep fractions, you could have done that. That would have been 6 2/3 plus 8 plus 6 2/3. If you memorize your 6's forever. Final answer is 21 1/3 times 2. So that really becomes 42.664 if you want to stick with the decimals. That's right. Square units. It's only approximation. Unfortunately, you guys don't know how to do the exact answer yet. But you're really close to getting the exact answer. Wasn't that exciting for your first Riemann sum?
Wasn't the other one 2?
42.
Yeah, we had widths of 2, so we had 42 2/3.
The width of 1.
Okay. Yeah. All right, number 2. It's the same function, because he isn't giving me anything else. Same function, but now he wants left Riemann sum again. It's the same thing again, left-handed. This time, intervals of 1 unit. That means I'm going to have double the rectangles. You hear me? I'm still starting at 1. I'm going to go up to that dot, and I'm going to move over to just 1 unit. You see that? Then I go up at the 2, go up to the function, go over 1 unit, which almost touches the other dot, and come down. Then I go at the 3, yeah, I'm at the 3 now, go up to the 3, go over 1 unit. I think it's going to go outside the rectangle and drop it down. This is kind of a hassle to draw the picture. It's not much fun. You could probably get away without doing all the artwork if you don't really want to, but some of you are pretty good artists, so let me finish my picture is going to look like. You can correct me if I'm wrong. And I got one more to go. There it is. Now, what do you notice right off the bat?
Isn't it all the way to 7, not 8?
Oh, yeah, you're right. I did say, correct me if I'm wrong, I don't want to use an extra rectangle. Thank you very, very, very much. What do you notice about this? I still have area outside, like especially on the right side, and then I have area that's cut off underneath inside from the left side of the middle. But what do you notice differently? Do you think there's less wasted space? Do you think there's less over approximation pieces, less under approximation pieces? Yes, no? Well,
Yes.
you think about it.
Less over,
Less over? How about the under?
less,
Less too. So my area here will be approximately, let's get smart here. I'm going to do my length 1, width 1, plus length 2, width 2, dot, dot, dot. How many rectangles do I have?
6.
6. All the way to length 6, width 6.
You could take out, length.
The length stands for the heights.
Yeah, the heights. Oh, no.
They're all different.
Width.
The widths. How much is the width for each one? So I pull out the 1, so I'm now left with f of 1 plus f of 2 plus f of 3. I don't want to keep going. Plus dot, 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 f of 6. I think so, right? Or no, yeah, the left of the 6th one. Yes. Did I draw it right? I did. It's right here. F of 6 is this thing right here. And so if you were good at your calculator a minute ago, it's the same function. Now, please, I need other people to share that you know how to do this. If you don't know how to do this, I don't want us leaving today without knowing how to get your calculator to do all the busy work for you. So that's my answer approximately. So I don't need the 1 anymore. What's f of 1? Real quick. Same answer as before.
20 thirds.
How much?
Is it 20 over 3?
Oh, you're going to use fractions this time? Fine. 20 over 3. What was f of 2? We didn't do f of 2 before. What's f of 2?
23 over
23 over what?
3.
Is it really?
I don't know.
Does anybody agree with Yannick?
I meant the beginning.
Well, no, but you're doing it. I got other people just now decide. I think we need a calculator. F of 3, somebody? Somebody else?
8.
Did-
Yeah, 8.
I got
Yeah, we used it before, right? Jillian, did you agree with the f of 2?
7.66.
That is 7.66. Yep. Plus f of 4.
7.66.
That would be 7 2/3. That would be 23 thirds. No, it can't be the same. Is it the same thing?
Yeah.
Yeah.
Wow, that's weird. That was 4, 5,
20 thirds.
20 over 3. And then that was 1, 2, 3, 4, 5, the 6.
And 5.
Plus 5. All right. So it's just a matter of putting that all together, and we're getting an answer of,
1.664.
oh, wow, 664 again. So 41? Let's compare that to the other answer we had. Yes, but look at the answer. How much different is it? It went up 1? Interesting. All right. Left hand with intervals length of a half. Well, yeah, I know. This does get tedious. And trust me, I wouldn't do the same problem 10 times. But I think he wants to prove a point. We're going to at least prove a point with the first problem. So now I'm going to take a second and say, I'm still starting at 1. Then I'm going to have in the middle there, that's 3/2, I think, or 1.5. We're going to do fractions or decimals. What do you want to do?
Fractions.
Okay, then the next one will be a 2.
Wait, how are we going to get this on the calculator when you graph it then?
What do you mean graph it?
Because I use the table.
Oh, smart. You can actually tell your calculator what your x values are. In this case, you are going to go every x is spaced by 0.5. Let's see if I can do it with mine and see if you can make it fit with yours. Am I recording again? Yeah, I think I am. So I got 1, and then I have a 3/2, then a 2, Then that next x here would be 2.5, which is the same as saying what? 5/2. Then it's a 3, which is the same thing as 6/2. Then it's a 7/2. Then it's an 8/2, which is 4. And then it's a 9/2. Then it's a 10/2, which is 5. 11/2. Then it's a 12/2, which is 6. And then it's a 13/2. I think that's the last one I want. I'm not going to plug in the 7 anyway. So there they all are. So I got all the numbers written out, and it's just a pain. I don't even really want to draw it, to be totally honest with you, but I'm going to try to do it. You guys are better than me. You see better. So if I start at the 1, drop my perpendicular, then I go halfway in the middle, drop it to the half. I'm terrible straight lines. Then it's the 2. And each one is being dropped from the function. All right, I'm not going to draw no more because I can't do justice with straight lines. But let's come to one agreement. What a heck of a lot of rectangles. Yeah, I think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. Now, the secret of the sauce is this. Each rectangle is created from a diagonal from the function on the left side. So see that? Every one of these dots that are on the function is what's creating the each one is creating the, oh, it's hard. And then that's the last one. See that? Can you?
This is a very large calculation.
Well, and the thing about it is, this is the underestimated regions. It's not a whole lot, guys. And then here are the over-approximated regions. If I was a betting man, I'd be saying that they're almost balancing out, almost. And if they balance out, it's an almost perfect answer, almost. Anyway, long story short, my area is going to be approximately, factor out the width. What's the width? A half. So now I have f of 1, f of 3/2, f of 2. I'll just do it in terms of halves. This was 2/2, 3/2, 4/2, 5/2, 6/2, which I know is 3, 7/2, all the way to the last one was what? It was 6.5, which is 13/2. It's right here, all the way to 13/2. So I'm just going to write ... 13/2, f of.
How come you don't include the 7?
7 is the right side of the last rectangle. We're only doing the area from the, oh, I missed one here when I didn't do the picture. We're going all the way to 7. I missed a half a rectangle. Yeah, you're right. I missed some there. That changes my thought then. I think the same thing's happening. I have more over than I have under again. Anyway, so if you figure out a way to do that with your calculator really fast, with your f of, you can get the answers real quick. So why don't, instead of writing all the numbers out, try to plug them in, guys. And if it's too much work for you to handle, then what's going to happen is when the push comes to shove and you really have to do it, you're not going to be able to do it because you didn't practice it. You figured it out?
Well, I don't know how.
Oh, I don't how to do. Well, do it by hand then. I mean, I can't use Inspire at all. But do you know how to do a function evaluate at a number?
Yeah.
Well, you can do that. You can do function evaluated at 1 plus a function evaluated at 1.5 plus, and just keep doing all 12 of them. It's not pretty. Good news though, AP exam never has you do this many. The most they ever have you divide up by is like 4. Why? They don't need to know that you can do all this stuff. If you can handle 4, then you understand the concept of Riemann sum. This is overkill. Anybody? You have an answer?
No.
Oh. Okay, raise your hand if you're actually trying to get it done. 1, 2, 3, 4.
Did I put 7 in there? No, right?
Not 7. The highest was 13 halves. Not 14 halves, but 13 halves. Yeah, if I had the Inspire, I'd have to do it one at a time. But there's got to be a way to set up your table values. Oh, wait a minute. There is a table set up. There is a table, because I know in statistics it's done where you can say, let all your x's, list your x values and list your y values. And then you can plug in the, your y values are a function of the x. I know that to be true. I just can't use the Inspire. I can't see it. Anybody got a number? I'm expecting it to be a little bigger than 41 2/3.
Yeah, seems that way.
But I don't know how.
40.911.
3?
40.
Oh, it went down?
40.91. I could be wrong because I had to manually input.
Hold on.
9, yeah.
Said 13 halves of the last one.
Yeah.
Alright, so that's.
I actually think
Well, hold on. We'll see if somebody gets a second opinion.
oh gosh.
It's okay if you're wrong. I'm sure I'd type something in wrong. Anybody, come on, somebody, Jillian needs some support.
This is a long thing.
It is, and you wouldn't want to do too many of those like that. Because who has the time, who has the patience? Another minute. Anybody close?
No, particularly.
I want to move on, but I don't want to leave you hanging. Who's sleeping right there? Oh, nobody. Just stuff on the desk. Who's their head all the way down? That's okay. No, I just thought somebody was sleeping. That shows you're involved. It's not like you even woke up to say that. Glad to join us. Is your sugar levels okay? Just checking. Got to call the nurse. I got a kid in a coma over here. Anybody? Come on, guys. Anybody close? Or I'm moving on. Get him some sugar.
I
ASAP.
got 40.917.
40.917. Oh, that's so close. Yeah. I mean, yeah. I'm going to run with it.
I got 40.9115.
Okay, that's okay. It's in that area, guys. All right, what else is happening? All right, I'm not going to do all of them. Let's just do one here. The right-handed sum. Same problem. Same function. But here's how it works. We wanted to divide it into 2 again. We're still starting at set 1. So I'm going to drop that line. Well, that's terrible. Come on. I'm going to drop the 1 at 7. And you know what you can do? Drop, there's 3 of them, right? 1 plus 2 is 3. So we'll go to the 3 here that goes up to that dot. Add 2 more.
From the left.
This time, the rectangles are formed from the right side. So we're drawing to the left. Drawing to the left of that rectangle. Drawing to the left. Remember, you're on the left side, touching the function. Draw left. And then left side, right side, draw left. Can you visualize that? Was that a little easier to visualize? Now that we've already done a whole bunch of ugly ones.
Wait, this is the next page.
Now, what changes in this problem?
It's 2 units.
A is approximately 2, factor the 2 out. And my height comes from what? F of 1 or F of 3?
Wait, what?
F of 1 or F of 3?
I guess you just did the reverse of F of 3.
F of 3. That's the right side of this rectangle. Plus F of 5. Plus F of, now we are using the right side endpoint 7. And the good news is you've used most of those numbers maybe at one point or another with the last problem we had done. There's got to be in those 3 problems we did. Every one of those is in there, except for maybe F of 7. F of 7 we didn't use ever. So what was F of 3?
Yeah.
What was F of 5?
6.66.
6 2/3. What was F of 7? We don't know.
2.66.
Yeah.
2 2/3. That gives me 2, and that gives me 8 plus 6 is 14, 15, 16, 16 4/3. That's 17 1/3. 17 1/3. I'm doing it in my head there.
Okay, 6.64.
So that's 34.664.
Yeah.
Why was I not thinking it was going to be a 7? Oh, 1/3. Oh, wait, it's a 1/3. It's not 6 6 at all. It's a 3 3. Oh, I'm doubling it. But I'm doubling it times 2. So it's 34.667, isn't it?
Yeah.
Okay.
It's because I'm using decimal.
Oh, yeah. And so if we're going to do lengths of 1, well, then you're going to have to draw all the rectangles length of 1. How many was there going to be? Well, we start at 1. That gives me 1, 2, 3, 4, 5, 6. But the key is, even though this seems to be where I start and this seems to be where I end, I don't measure from this black line that I drew. I got to go to the right side one length away. This one determines the height. Then keep going, follow the pattern. This one determines the height. This is the height, and we're drawing to the left to make a right-handed. And there they all are. So what were my measurements that I used? I used a 2, so I'm going to need an F of 2 for sure. I used 3, I'm going to need an F of 3 for sure. I'm going to need an F of 4 for sure. F of 5 for sure. F of 6. And the F of 7. And it was all times a 1 because that was the width of each of those. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Starting at the 2, add 1, add 1, add 1, add 1, add 1. And again, and if you look at those answers and compare them to the other page, how far is that answer off from the very first one we did? It's kind of an interesting look. All right, what was F of 2?
7.66.
7 2/3. What was F of 3?
8.
What was F of 4?
7.66.
7.66.
Yes.
7 2/3. What was F of 5?
6.66.
6 2/3. What was F of 6?
5.
And F of 7?
2.66.
Okay, 2.66. That's 2 2/3, which was the same answer as before. So all we got to do is add those together.
37.664, but I guess it'd be 667.
Yeah, I think so. Yeah, because you're rounding every single time, right?
Yeah, I'm using decimals.
So use more decimals.
Oh, I only have up to 3.
Well, you can change your settings to be float. Or you can
On the
type,
calculator?
oh, you mean your tables only show, wait, are you getting from your table? Yeah, you should be able to get more decimals.
Because I added up in the calculator. Like, I get the values from the table, and then I add that in the calculator section.
Yeah, there's got to be a way to make it more accurate because you don't want to be wrong in the, because you're allowed to say 666 or 667 would be a right on the AP test. So we need to make sure you figure out how your calculator can be changed. But anyway, I'm not going to keep going. The point is we could divide this now by every half, and that was a pain in the donkey, wasn't it? So anyway, before we continue, what inference can be made about the approximations as the side lengths of the rectangles decrease? As the widths got smaller and smaller and smaller, give me a general epiphany you had.
Became more accurate.
Well, you think so, but we don't even know the exact answer, so how do you
Or
know?
less over and under.
I like that better. We're saying possibly more accurate because less, how'd you write it? Under
And over approximation.
and over approximation. Approximations, how's that? Generally, why do you suppose this is so? Well, you just said both in here. You not only did you say more accurate, but you said because there's more, there's less wasted area, there's less unused area. So that's the idea. All right, what's he doing now? Okay, I promised you this, midpoint. I'm not going to do all the way to the half bit. It's too hard. It's not even tested. Bless you. Same function, and he at least made it easy. It's the same function every page, from 1 to 7. And we're going to divide in 2 again. So let me do that first. Start at 1.
Are we doing it from the?
I'm going to the 3. I'm just drawing the 3 lines. Going to the 5. Well, the 7 is here too. So there's my rectangles. But yes, how am I going to create my heights? From the midpoint. That means, here's my first rectangle. What's the middle between 1 and 3? I got to go to the 2 here. So I go up to the 2 to where it touches the function. Now I go halfway left, halfway right. So there's that first rectangle. Let's do the second rectangle. What's between the 3 and the 5? 4. So I go up to where the 4 touches the function, go halfway to the right, halfway to the left. And there's my rectangle. Last one. What's the interval between those 5 and the 7? So I go up until it touches the function, go halfway left and halfway right. Before I even do the work, what does it look like with only, remember, this is still lengths of 2. What do you think has happened by using midpoint? It's all over approximation. Not one of these was under, were they?
Yeah.
Maybe one was in the middle there, kind of, I don't know, maybe. But do you think overall it'd be more accurate or less accurate? Now, you might be right that our answers are going to be an over approximation, but maybe it's not that much over. So the only difference is my area still will be, factor out the width of each of these. Well, the width is still a 2, still a 2, still a 2. But now I'm doing f of 3 plus f of 5 plus f of 6.
6,
Right?
7.
No, I'm in the middle, somewhere.
Oh, then you,
Right here.
then it's
Wouldn't
a-
it be 2?
Then wouldn't it be 2, 4, and 6?
Oh, yeah, maybe you're right. 2, oh, yeah, 4 and 6. Thank you. I should have zoomed in. So is 2, what was f of 2 again?
7.72 house.
7
I
and
mean, 7 and
2/3. What was f of 4?
7 and 2/3.
Again?
Yep.
What was f of 5?
6.
6.
5.
6, I mean. Which is it?
5.
It's a 5. 2 was a 2, 4, and 5. No,
Yeah.
2, 4, and 6.
Yeah, that's fine.
So 6.
F of 6 was 5.
Oh, it is a 5. Okay. So it'd be interesting to get the exact answer. And really quickly, what would midpoint be with lengths of 1? I'm not going to do that. It's just
20 and 1/3.
I think
Oh, wait,
about,
it would be 40 and 2/3.
yes.
Yeah.
what? Which this final answer?
Yeah.
How much?
40 and 2/3.
Yeah, 40.
That answer looks very close to some other answers we've had. They're all in the same ballpark, aren't they? And I just don't want to do midpoint with the unit length of 1 because it's going to be really hard. I'll try it just for kicks. But I'd have to go in the middle between 1 and 2. I'd have to draw up to the function,
We're in the middle.
and well, because it's midpoint. Because I want my top to look like this.
Oh, I see.
I want that. There's my rectangle. And so it's going to be too many of them. It's not much fun. It's just too much work, I think. Well, went too far. You can get the idea. As long as you understand what it is, function here. And I'm going to show you how to get the exact answer. Do I dare do this to you? No, I better not.
Yes.
No, because then I'd have to show you that there is an integral from a to b of f of x
No.
dx. And that gives you the exact answer.
For the AP, do you have to know the exact answer?
Well, yes. Yes, you would have to, yes. Man, a lot of you guys go, I'm an old man and I'm here the whole period and I sit here and I don't even, where it depends yet. I'll wait till June. I won't be in school no more, so I can wear whatever I want.
But the pens are like adult diapers, aren't they?
I don't know. I just hear about them all the time.
Oh.
I hear they're so comfortable.
Oh.
That's what Grandpa said. I just recorded that. Sorry, Grandpa. Sorry, Grandpa. Didn't mean to. What is it called when you? I put him on blast.
Oh.
Is that what it is?
Who taught you that?
I don't know. I was going to say gaslighted, but I thought, no, that's not right. This is called the definite integral. It's when you can actually find the exact answer from A to B without approximating with Riemann sums. Riemann sums is the approximation of the definite integral. Up to now, when I just do integral of f of x, this is called an indefinite integral.
Wait a minute.
It's indefinite because our answer always has an answer plus a c. And I don't always know what c is, so I don't have a definite answer. It's indefinite until I have something to find c, okay? This is always definite. We'll have the exact decimal answer. Your calculator does it. You guys that have figured out how to key in a function with your Inspire or your 84, you can pick the one from A to B. Matter of fact, let's do that. Oh yeah, you always got to add the x to the variable if you're integrating it. So,
What do you do?
oh, look at this one right
What
here.
do B and A stand for?
The what? A and B? Left endpoint, right endpoint. We went to 1 to 7.
Oh, I get why it didn't work,
So
okay.
go, do you press like graph or table?
No, I'm in the blank window. I went to the,
So how did it tell you the end? Oh, it just says 40 like all the.
exactly, on the screen.
Is B the endpoint?
Yes. Like where's the last part of the function that we want to get area up to? So look at this.
I figured it out.
There you go, see?
Fire.
Yeah, there you go. See? So look at our last answer was 40 and 2/3. That was our best answer. So I have a feeling that midpoint is probably a pretty good approximation because we didn't even do the halves. Can you imagine if we had done the halves with the midpoint? I can only imagine because I'm not really going to do it. I can share with you the solution, but I don't want to do it. I don't want to do that work. Okay, hold on here. What time is it? I want us to go back to the... All right, let's talk about the last thing you should know. Trapezoids. This is definitely on the AP test often. They'll usually say this. You're going from 1 to 7 of this function, and we want trapezoids of lengths of 2. Well, guys, we're only going from 1 to 7. It's going to be the same number of trapezoids as there were rectangles. But watch this. If I'm starting at 1, and I go 2 over, then I go 2 over again, and 2 over again. I went 1 to 7. Now, here's the trapezoids. Pay attention. If you paid attention to very little up to now, pay attention to what I'm going to do here. I'm going to connect this endpoint left with the right, and I'm going to draw a straight line. What do I have? What's this picture here now that I'm covering in blue? This is a trapezoid standing on one end that's flat. See that? It would look to you more like this. See that? That's a trapezoid. Trapezoid has a height here. Well, we call it a height, and we call this base 1 and base 2, right? But in this picture here, I call base 1 this one here, base 2 this one here, and this distance down here is the height. Again, it's the same thing as we did with the rectangles. The width was always the same. Well, each of these, the height of each trapezoid is the same. It's a 2, it's a 2, it's a 2. But this base 2, now this one, I'm going to connect connect the left and the right, connect them. There's your trapezoid. And I'll call this base 3. I mean, it's just another base. And the last one here, connect the left side of the rectangle, the right side, and that's almost a perfect fit. Matter of fact, it's almost an illusion. Perfect fit. And I'll call that base 4. So now you got 1, 2, 3 trapezoids. Well, by hand, it'd be nice if we knew the area of a trapezoid. Does anybody know the area of a trapezoid?
I want to say
Isn't it base times height divided by 2?
Or is it
It is
Half H base 1.
1/2 times what?
H
Oh, times h. You're right. There is a times h in there.
base 1 plus base 2.
One of the bases plus the other base. That's right. Or you put that h, you said 1/2 h. Would that be h over 2?
Yeah.
Base 1 plus base 2? Perfect. We'll use that formula. That means all 3 of these trapezoids use the same h and the same over 2. Is that correct? Hello?
Yes.
Yes, they all have 1/2 h, 1/2 h, 1/2 h. And h is constant in here. So my answer for this one will be approximately, I'm going to factor out the h over 2. And I'm only going to need to go base 1 plus base 2. Base 1. Well, let me fix that. Base 1 plus base 2 plus, what are my bases for the second trapezoid?
Base 2 and base 3.
Yeah, exactly. Base 2 plus base 3. How about the third trapezoid?
Base 3 plus, wait,
Yeah,
base 1,
yeah, base 3 plus what?
base 4.
Exactly. Well, if you looked at the pattern, check this out. H over 2. It'll always be this. Base 1, there's only one of them. Base 2, there's two of them. Base 3, there's two of them. Base 4, there can only be one. Does that make sense?
Yeah.
It'll always work that way. 1, 2, 2, 2, 2, 1. Now, where am I going to get those base measurements? I know the height was 2. So it's always going to be 2 over 2, which is a 1 that cancels out. But what is base 1? What is that really in terms of the function?
6 and 2/3.
Oh, you're ahead of me then. Well, that was f of 1, wasn't it? Then it's 2 f ofs, was it 3s?
Yeah.
What's the H?
H is this distance down here.
So it's just 1.
Yeah, it's going to turn just to 1. 2 over 2 becomes just a 1. That's right. But so I have 1 f of 1s, 2 f of 3s, 2 f ofs, 5s, and that's it. 1 f of 7. And we have all those numbers. I wonder how good this answer is going to be close to 40. What is f of 1 again? 6 and 2/3. What was f of 3 again? 2 of the 8s. What was the f of 5s?
6 and 2/3.
And what was the 7, f of 7?
2 and 2/3.
Okay, so if I clean that up, I have 6 and 2/3 plus a 16 plus
38.6?
12 and 4/3, that's 13 and a third. And then 2 and 2/3. Okay, I'll see what you're right here. 6 plus 16 is 22. Plus 13 is 35. 36, 37. That's 37 so far. I have 2/3 plus 1/3. That's 3/3 plus 5/3. That becomes 38 and 2/3. Is that what you had?
Yeah.
Okay. I was going to say, that's not close to 40, is it? But it was only 3 trapezoids. That's a better answer than I had with rectangles. Because 40 is the magic answer, remember? And that's the most that the AP test will have you do. Using trapezoidal rule, actually you could come up with a function. Using trapezoidal rule, approximate the area under the curve from 1 to 7 using 3 trapezoids. That means you got to divide the 1 through 7. You got to make sure you create 3 equal lengths down there. That was a mouthful. I don't know if I want to do more. Trapezoids with a length of 1. Do we have the time? Not really. But maybe I'll add it to the video before I post the whole thing. This was a chart you're supposed to go through and put all your answers.
Oh, and then to like see why.
Yeah, and they're going to see what you think the answer is going to be. But we already kind of cheated. We know what the answer is going to be. And then there's some practice problems. So I think this is going. Here's what's going to happen. I think I may not be here on Wednesday, so I'll finish up all this lecture, and then your assignment Wednesday will be to do this homework. Deal? And grade the other one. I'll provide you the solutions. Require a little